So before I continue, we should discuss all the fields in the hello packets that you should memorize and know. And these fields are the router ID. The hello packet contains the router ID of the router originating the hello and dead timers, the hello timer being the timer how often I send hellos, and the dead timer being how long should I wait to hear from a neighboring router before considering it down. So before considering it dead. So how long a neighboring router should wait for me to send another hello before considering me down. All your neighbors' router IDs, which means all my neighboring routers, their router IDs will be contained in hello messages that I am sending. The area ID of the originating interface, this won't make sense right now, it will make sense in a little bit. For OSPF breaks down a large network into smaller, easier to maintain areas. And these areas have an area ID. As we get to our lab, this will make more sense. The router priority, the OSPF router priority, which remember I said by default is 1 and it can range between 0 and 255. The router with the highest priority becomes the DR. The DR IP address, or the designated router IP address, the backup designated router IP address, and any authentication information if present. Now, after two routers exchange hellos with all this information, they become neighbors. Once they become neighbors, they start their database exchange or link state database exchange. And this exchange happens in 1, 2, 3, 4, 5, 6, 7, 8 steps. Well, 7 steps. The last one's when it ends. So, two OSPF neighbors start in the down state. This doesn't mean that the router is down, it just means they start in a state called the down state. So in the down state, a router has received a hello from the opposite end. Then the routers transition to the attempt state. Now the attempt state is only seen in non-broadcast multi-access networks like frame relay, which we will tackle later. So, in the attempt state, neighbors must be configured manually with the neighbor command. However, OSPF over frame relay is not part of CCNA, but I will attempt to show you the neighbor command. Next, we move on to the init state, which means that the hello packet has been received from the opposite side or from a neighboring device. Next, we move on to the two-way state, and this state means that I have received a hello packet from my neighbor with my own router ID in that hello, which means that bidirectional communication has been established. Next, routers move on to the X-start state, where routers prepare for link state database synchronization by exchanging packets called database description packets. The router with the highest router ID amongst all becomes the master router and controls the database exchange with the other routers. Then you move on to the exchange state. In the exchange state, database description or DD packets, link state request packets, and link state update packets are used to exchange the link state database between two routers or two or more routers. In the loading state, link state request packets are sent requesting missing link state advertisements or LSAs that I might have missed from you, that you might have in your link state database but haven't sent to me yet. These link state request packets are responded to by link state update packets containing these LSAs. Once this exchange is completely done and the two routers databases are completely synchronized, you move on to the full adjacency, or you have fully exchanged your databases with each other, so you are in the full state. This ends the neighbor state machine lecture.